Welcome to The Explainer. Today we're pulling back the curtain on what is essentially an invisible war. It's not being fought with traditional weapons, but with data streams, pipelines, and power lines. We are talking about the silent, massive transformation of our global energy infrastructure, and it's something that is about to completely redefine how the entire modern world operates. Imagine this just for a second. What if you could literally pause an entire country, make an exact digital copy of it, and then run thousands of simulations before you ever had to make a single real-world decision? Now, I know that sounds like a sci-fi movie or some crazy world-building video game, but it isn't. This is a very real, incredibly practical tool that top engineers are using right this very second to manage our reality. So, let's start small. Engineers call this concept a digital twin, and it is exactly what it sounds like: a virtual, digital copy of a real-world physical object or system. Initially, this brilliant concept was just used for single, isolated machines. Think of a massive jet engine on a commercial airliner, or a lone wind turbine out in the field, or a specific production line in a factory. They'd basically created a digital ghost of that one specific machine. But here's the thing: a digital twin isn't just some static 3D model. It is absolutely alive with data. To make it work, physical sensors on the actual machine collect real-time data every single second. We're talking about tracking temperature, pressure, vibration, power output, the whole shebang. This relentless stream of information feeds directly into the virtual model. And because the digital twin mimics reality perfectly, it can actually predict when a part is about to fail, sometimes way before a highly trained human operator would ever even notice a problem. So instead of reacting after a breakdown and dealing with a massively costly repair, engineers can just intervene before the problem even happens. It's a real game changer. But what happens when you take this concept and scale it up to an entire nation's electrical grid? For over a century, electricity followed a super simple, predictable path. From a giant power plant, through a transmission line, to a substation, and finally down to your house. One direction, one massive producer, millions of passive consumers. It was simple and it was reliable. But renewable energy completely shatters that old model. Now you have millions of small generators, rooftop solar, offshore wind farms, even electric vehicles, all feeding power back into the grid, creating this staggeringly complex, incredibly flexible system. As a result, grid operators are facing an absolute engineering nightmare. Seriously, imagine trying to conduct an orchestra with millions of musicians who all decide to change tempo every few seconds. That is exactly what we're dealing with today. Without incredibly advanced software, that orchestra of millions of unpredictable renewable generators quickly devolves into total chaos. Let's look at exactly how fast things can go off the rails. Picture this. A single, giant cloud happens to roll across a massive solar farm right in the middle of the afternoon. In an instant, local power production completely plummets. The grid has to compensate instantly. But at that exact same moment, maybe hundreds of kilometers away, wind speeds suddenly and unexpectedly increase, causing this massive surge of power from a wind farm to just slam into the grid. And while the grid is frantically trying to balance the cloud cover and the sudden wind surge, the workday ends. Electric vehicle charging spikes exponentially across the entire country as everyone gets home, right as major industrial factories begin spinning up their heavy machinery for the night shift. All of these variables are happening simultaneously. Balancing this intense, ever-shifting supply and demand is, without a doubt, one of the modern world's most difficult engineering problems. Human reflexes simply aren't fast enough to handle this anymore. Enter artificial intelligence. Now, most people hear AI and immediately think of chatbots or weird image generators, right? But AI's most critical role is actually way less glamorous. It's energy optimization. An AI system can forecast electricity demand hours in advance. It notices a weather front moving across a region and instantly predicts a drop in solar production while anticipating stronger winds offshore. Then it recommends a solution, like, hey, let's charge those massive industrial batteries right now rather than later. When you combine this with a digital twin, operators can test these incredibly complex strategies virtually before ever applying them to the real grid. The result? It isn't just about saving money. It is quite literally about keeping the grid from collapsing entirely. And this brings us to Europe's highly ambitious vision for the future of energy. They aren't just stopping at a smart electrical grid. They are layering in hydrogen. You see, electricity moves through cables, while hydrogen moves through pipelines. Together, they are being engineered to create two distinct, yet deeply interconnected energy networks running in parallel across the entire continent. Across Europe, you have this sprawling hydrogen pipeline network rapidly developing. Some of it newly built, some of it converted from old natural gas lines, all designed to connect distinct regional strengths. Think about it. Spain has phenomenal, abundant solar resources. Up north, The North Sea boasts exceptional offshore wind capabilities. Over in Scandinavia, you've got extensive, reliable hydropower. Different regions possess very different natural advantages. By connecting these regional advantages through electricity and hydrogen pipelines, you're essentially creating a continent-wide safety net. Think of it like the internet. No single computer powers the internet, right? Its strength comes entirely from its connection. Europe is applying that exact same decentralized principle to its energy. If the wind dies down in the North Sea, the solar in Spain or the hydro in Scandinavia can instantly pick up the slack. But energy isn't just generated, it has to move, and this reality is completely transforming the global map of trade. For decades, major ports were basically just gateways for coal and oil. But the future? The future belongs to hydrogen and hydrogen-derived fuels. Right now there is a fierce, high-stakes competition between major ports like Rotterdam, Antwerp, and Hamburg to become the dominant energy hubs of tomorrow. Governments and massive companies are pouring billions into this because the economic stakes are just enormous. So, why are they betting so heavily on hydrogen? Well, it's because heavy industry absolutely depends on highly reliable, incredibly dense energy. We're talking about steel production, massive chemical manufacturing, transoceanic shipping, heavy commercial transport. You simply cannot run a massive steel forge or a giant cargo ship efficiently on standard lithium-ion batteries alone. They just require way too much heat and way too much continuous power. Hydrogen is absolutely essential for this next phase of global manufacturing if it's going to survive the green transition. Now, before we look at the geopolitical consequences of all this, I want to take a quick pause for a really fascinating detail. Did you know that a hydrogen flame is almost entirely invisible in daylight? It is completely true. If there's a hydrogen fire at a port or a factory, you literally might not see the flames at all. I point this out because it perfectly highlights how every single new technology brings incredibly unique engineering challenges. To handle hydrogen safely, we now have to invent and deploy highly specialized, invisible fire detection systems across all of these new facilities. Okay, so you look at this whole picture. Europe seems to have a totally utopian strategy here, right? We have renewable electricity, we've got an interconnected hydrogen infrastructure, smart grids, AI predicting the weather, digital twins simulating reality. It all sounds pretty perfect. So what exactly is the problem? Well, the crucial point is that beneath this elegant digital strategy lies a massive, critical, hidden weakness. You see, the digital world requires the physical world to actually function. All of this amazing software relies entirely on hardware. To make this green revolution work, you need electrolyzers to separate the hydrogen. You need fuel cells, massive electric motors, highly complex power electronics, and sprawling physical transmission systems. And every single piece of this hardware relies on deeply complex, highly concentrated global supply chains. The weakness isn't in the software, it's inside the rocks. It is inside the mines. Our entire digital and clean energy future is almost completely dependent on physical materials that most of us never even think about. We need immense quantities of platinum, iridium, copper, and highly specific rare earth minerals. And here is the truly scary part. These materials are incredibly geographically concentrated. They are found and processed in just a handful of countries around the entire world. Because of this, the energy transition is not just a bunch of countries trying to lower emissions independently. It is actually a massive, deeply interconnected global competition spanning across multiple continents. Just consider the reality of this supply chain. The physical mines pulling the copper and iridium out of the earth might be in Africa. The highly toxic, complex refining of those rare earth minerals might happen entirely in Asia. The brilliant AI technology and digital twins, designed in Europe. And the massive capital financing to build the whole thing might come from America. This deeply fragmented supply chain is creating the defining geopolitical shift of our era. In the 20th century, the question that drove global politics, wars, and economies was super simple. Who controls the oil? But look at the 21st century. The new stark reality is who controls the materials and the manufacturing needed for clean energy technologies. Because whoever controls the materials and the manufacturing controls the future of the global economy. Which brings us to the ultimate question we have to face today. We've seen the brilliance of digital twins. We absolutely understand the necessity of AI managing these chaotic power grids. We see the sheer ambition of the hydrogen pipeline. But in this intense global competition for the actual physical industrial leadership, the refining of the rare earth minerals, the manufacturing of the electrolyzers, the production of the batteries, who has quietly, over the last 2 decades, built an extraordinary, almost insurmountable advantage? China. While the rest of the world was heavily focused on the software of the future, China relentlessly secured the physical hardware. They completely dominate the refining and manufacturing that makes this entire green revolution possible. We know the digital technology will work, but as this vast new infrastructure is built, the ultimate question is this. If the entire modern world relies on a smart green grid to survive, what happens when one single nation holds the keys to turning it on? Thanks for joining me on this explainer, and I'll see you next time.